Hey guys, today we only have 3 short examples to go over because we are going to be working on Pythagorean theorem with word problems. So it's going to require a little bit of reading. I highly suggest that you draw a picture to help you manage the problem and know exactly what you're looking for and what you need to do to solve it. So if we can take a look at this, your first example, and I will say there are copies of these notes posted on Canvas, so if you wanted to pull that up and kind of go through those examples as I'm going through them on the board, that might be helpful. Number 1, Joe is going to the park. He drives 3 miles south and 5 miles west. How far is he from home if he goes the most direct route? Okay, so here's my picture. Joe starts here. This is his home. He's going to drive 3 miles south, and he is going to drive 5 miles west. Now, what we created when we did that was a right angle. I want to know the direct route back home, so that is going to create my hypotenuse in my right angle, which is what I'm going to be solving for. So this would have to be C, this can be A, and this can be B. Remember, your A and B can be interchangeable, so it's okay if you put A here and B here, but this has to be C, and that is what we are searching for. So, just to refresh our memory on our Pythagorean theorem, A squared plus B squared is C squared. And we are solving for a missing side of our triangle today. We're not trying to prove that this is a right triangle like in our previous lesson. We know it's a right triangle. We need to solve for the missing side. So my A value is 3, so 3 squared is going to be 9. My B value is 5, so 5 squared is going to be 25. And I don't know what C is yet. That's what I'm solving for. You're going to add together 9 and 25, and that is going to be 34, and that is going to be C squared. Remember from a couple of lessons ago, when we're solving for the hypotenuse, or C, that's when you're going to add and then take the square root. So the very last step I'm going to take is the square root. So you can do that in your calculator. You can do that in the calculator on your phone. If you don't have a phone with a calculator on it, you can type in the Desmos Scientific Calculator. That's probably the easiest one to use for that. Square root of 34 to the nearest tenth is 5.8, and that is going to be the value for C. Also remember, C has to be my longest side. So that does make sense because 5.8 is longer than 5 and is longer than 3. So the direct route home would be 5.8 miles for number 1. All right, number 2. A TV is 30 inches wide and has a diagonal of 33 inches. How tall is the TV? Now, most TVs are in the shape of a rectangle. And if you remember from a rectangle, the definition from a rectangle has 4 right angles. So here's what it says, that it is 30 inches wide, so that's going to be this amount. And it says it has a diagonal of 33 inches. So I want you to look at what happens when I sketch in the diagonal. That diagonal is going to be the hypotenuse, or the C value of my triangle. So when you have a triangle, or when you have a rectangle and you draw in a diagonal, what you create is a right triangle. I don't need this part of the rectangle, so I'm not even going to focus that. That's why I highlighted it in the darker blue for what we need. Since this is the diagonal, this has to be C. Your diagonal is always going to be C. It's always going to be the hypotenuse. I'm going to call this B, and the amount I'm looking for is A. That is going to be a leg. So you got to think about this a little bit differently when we're solving for a leg. A squared plus B squared is C squared. I don't know what A is, so I don't know what A squared is yet. B is 30, and if you do 30 squared, that is 900. and C is 33, and if you do 33 squared, that is 1,089. Now, we're solving for a leg, so we're not going to add in this step. We actually have to subtract. We're going to subtract 900 from both sides. So now we have a squared by itself, and 1,089 minus 900 is 189. Remember, your last step when you're doing Pythagorean theorem is to take the square root. So I have to take the square root of both sides. The square root of a squared is a, and the square root of 189 to the nearest tenth is 13.7. Double check yourself and make sure that C is still the longest side. So I've got a 33, a 30, and 13.7 would go right there. So that is going to be the longest side. All right, number 3. A baseball diamond is actually a square with 90 feet between bases. How far does a catcher have to throw when he throws the ball from home plate to second base? So a baseball diamond is going to be shaped like this, but it specifies in the problem that it's actually a square, so that means that all of these corners are actually right angles, because the definition of a square is 4 sides with right angles. I know mine's not a perfect square, so just pretend like it is. And it says it's 90 feet between bases. So this is home, this is first, this is second, this is third base. And so all of these would be 90 feet in between bases. So the question is, if the catcher throws the ball from home plate to second, how far is that? Now, if you can picture this kind of turned on its side and you forget about this part of the problem, what I have right here is a right angle, and this is my hypotenuse, because these two are the legs. The hypotenuse is across from the right angle, so I'm going to call this A, I'm going to call this B, and what I'm actually searching for here is C, or the hypotenuse. So we're going to do 90 squared plus 90 squared equals C squared. So if you do 90 squared plus 90 squared, 90 squared is going to be 8,100, and another 90 squared is going to be 8,100, and that is going to be C squared. 8,100 plus 8,100, I can add this together. That is going to be 16,200, and that is going to be C squared. And your last step is to take the square root of both sides, and C to the nearest tenth is going to be 127.3 feet. Make sure that's the longest side because it is the hypotenuse. So if you have 90 and 90, 127.3 is going to be the longest side. Please join me tomorrow for the Zoom session if you need help setting up these problems. I know sometimes it can be hard to see exactly what it's asking you to do and how to set it up, so I do not mind setting those up for you. Check your email for the Zoom invitation, and I will see you then. Thank you. Good night.